M.S. Ramaiah University of Applied Sciences.
Hi students, let us have a discussion on verification of maximum power transfer theorem. The objectives of this laboratory experiment are to verify Thevenin's theorem and to verify maximum power transfer theorem. Statement of Thevenin's theorem. A linear two-terminal circuit can be replaced with an equivalent circuit of an ideal voltage source VTH in series with a resistor RTH. VTH is equal to the open circuit voltage at the terminals. RTH is the Thevenin's equivalent resistance when the independent sources in the linear circuit are turned off. Steps to determine VTH. Identify the load, which may be a resistor or a part of the circuit. Replace the load with an open circuit. Calculate VOC. This is VTH. Steps to determine RTH. Turn off all independent voltage and current sources in the linear two-terminal circuit. Calculate the equivalent resistance of the circuit. This is RTH. Statement of maximum power transfer theorem. Maximum power transfer theorem states that the maximum power gets transferred from source to load when source bar Thevenin's resistance is equal to load resistance, that is RL is equal to RTH. To verify this experiment, we need breadboard, digital multimeter, resistors, DC power supply and connecting wires. Construct the given circuit on the breadboard. Choose appropriate resistors and measure their values using the digital multimeter. Now, fix digital multimeter on the MA in DC range and connect in series with the load resistor on the breadboard to measure current flowing through the resistor. Now, apply voltage source to set a particular value by using RPS. Now measure and record the current flowing through the load resistor and verify the same using Thevenin's theorem. To find VTH, remove the load resistance and fix the digital multimeter on the DC voltage range to measure the open circuit voltage across the load resistor. To find RTH, to find the Thevenin's resistance, remove the RPS and short circuit it and find the RTH using digital multimeter. Now connect the Thevenin's equivalent network on the breadboard and fix the digital multimeter on the MA in DC range and connect in series with the load resistor on the breadboard to measure current flowing through the resistor. Now apply Thevenin's voltage by using RPS. Measure and record the current flowing through the load resistor and verify the results. Calculate the power delivered to the load using appropriate formulae and verify maximum transfer theorem.
Hello students, we are performing maximum power transfer theorem today. Aim of this experiment is to perform Thevenin's theorem and verify maximum power transfer under various load conditions. Components required to perform this experiment are: this is regulated DC dual power supply. This is used to supply DC source for the experiments. This regulated power supply has two output terminals. So this is main power supply switch. These two are the voltage knobs. This is for coarse setting and this is for fine setting and this is for current setting. There we can obtain two different voltages at two different output terminals. This displays the voltage and this displays the current given by the circuit. Any output terminals can be used to perform the experiment. multimeter. This is digital multimeter. Multimeter is a device used to measure various quantities in a single meter. In multimeter we can measure resistance, DC voltage, AC current, DC current, capacitance and connectivity of the circuit. This is common terminal of the multimeter. This black knob has to be always put in the common terminal. If we are measuring AC or DC voltage, the red knob has to be put in voltage position. If we are measuring AC or DC current in few milliamps, then this red knob has to be put in milliamp position. If we are measuring AC or DC current in terms of few amps, the red knob has to be put in 10 amp position. Resistors, these are the resistors that are used to build the circuit in this experiment. The value of this resistor is 1.5K, this is 100 ohms, this is 1 kilo ohms, this is 4.7 kilo ohms. The value of resistor can either be found out using color coding or multimeter. Breadboard, this is breadboard on which the circuit will be built to perform experiment. These are connecting wires used to build the circuit. Let us start the experiment by building circuit as shown in figure. Let's start building the circuit using breadboard, resistors and connecting wires. Take the breadboard. Using 1.5 kilo ohm resistor, start connecting the circuit. Next we will take one more 1.5 kilo ohm resistor and connect in series with previous resistor. We will take 1 kilo ohm resistor and connect in parallel with both the resistors. Now we will connect load resistor. Now we will short the ground terminals using connecting wires. Now we will give supply to the circuit using connecting wires and connecting to the dual regulated power supply. The positive terminal is given to the first 1.5 kilo ohm resistor point. The negative terminal is given to the ground point. Now the circuit is built, we can perform the experiment. Let's start performing the experiment. Before starting the experiment, make sure that voltage knob is in minimum position and current knob is in maximum position. Now let's turn on the power supply and apply 10 volts. Let us now measure load current using multimeter. Let us fix the multimeter position to the DC ammeter position and put the red knob to milliamps position. To measure load current, remove the first terminal of load and place it in some position where no connections are there. Now let us measure current between those two positions using multimeter. The value of load current is 0.58 milliamps. Now let us check the open circuit voltage or Thevenin's voltage. To verify Thevenin's voltage, we need to remove the load resistor and measure voltage across the load terminals. Therefore, we are removing the load resistor. Now we shall put the multimeter to DC voltage position and put the red knob to voltage measurement position. Now we will measure open circuit voltage across load terminals. Thevenin's voltage is 3.92 or open circuit voltage is 3.92 volts. Now we will measure Thevenin's resistance value. To measure Thevenin's resistance value, you need to turn off the power supply. So we will bring DC supply to 0 and turn off. We will short the supply terminals. And measure the value of Thevenin's resistance using multimeter, keeping the knob position at 20 kilo ohm position. Thevenin's resistance is measured across the load terminals, open circuited load terminals. The Thevenin's equivalent resistance is shown as 2.05 kilo ohms. Practically, the value theoretically is 2.1 kilo ohms. The variation in this value is because of the tolerance present in the resistors. First part of the experiment is completed. We built the actual circuit and found out the open circuit voltage value, that is Thevenin's voltage, and we also found out the Thevenin's resistance value. The second part of this experiment will build Thevenin's equivalent circuit using the obtained values from first part. The Thevenin's equivalent circuit is as shown in the figure. We will build the Thevenin's equivalent circuit on breadboard. Let us start building Thevenin's equivalent circuit. Thevenin's equivalent resistance value is 2.1 kilo ohm. Approximately I have considered 2.2 kilo ohm to perform the experiment. 2.2 kilo ohm resistor is taken. And we are connecting load resistance of 4.7 kilo ohm in series with it. Let us start giving supply using connecting wires. The positive end is connected to the first end of 2.1 kilo ohm resistor. Taking another wire from negative terminal, it is connected to the farthest end of the 4.7 kilo ohm resistor. This completes Thevenin's equivalent circuit. Now we will measure Thevenin's load current. Now we will turn on the supply, apply Thevenin's equivalent voltage, that is 3.9. and measure load current. To measure load current using multimeter, we will keep the knob at 20 milliamps DC current position and fix the red knob to milliamps position. Remove the load terminal and place where no other connections are there. Now we will measure load current between those two terminals. it is 0.55 milliamps. This completes second part of our experiment, that is Thevenin's equivalent circuit and verification of Thevenin's theorem. Moving to the third part of the experiment, we will perform maximum power transfer theorem using Thevenin's equivalent circuit by changing the value of load resistors and taking the load current values. To perform maximum power transfer theorem, the circuit is equivalent circuit of Thevenin's equivalent circuit only. We will vary the load resistance. First one would be 4.7, which is already in the circuit. We will measure the value of current for two more resistance values, that is 1 kilo ohm and 2.1 kilo ohm. Now let us measure the current value for 4.7 kilo ohm. We are getting 0.55 milliamps. Now we will replace 4.7 kilo ohm resistor by 2.1 kilo ohm value and take the load current. Now let us measure the load current. Value of current is 0.87 milliamps. Now let us remove 2.1 kilo ohm resistor and perform same step for 1 kilo ohm resistor. For 1 kilo ohm, the current value is 1.19 milliamps. We are done with our third part of the experiment, that is maximum power transfer theorem. We took load current values for three different values of resistor, that is 4.7 kilo ohms, 2.1 kilo ohms and 1 kilo ohm resistors. The obtained load current values can be used to calculate the powers and verify maximum power transfer theorem.
At MSR UAS, we spark your imagination unlike any other.